Yeah, welcome everybody to the April Sustainability Series. We're excited to welcome Bryan and Dan from ADS to speak to sustainable stormwater infrastructure and also a product type that their group manufactures that can help address those needs. I did want to just acknowledge that we're one day before Earth Day, so we're excited to have kind of an Earth Day sustainability series this month, but also contribute and celebrate Earth Week with this presentation. So thanks for being here today and your busy schedules. And with that, I'll get out of the way and let Bryan and Dan introduce themselves, and we'll get going as part of the presentation. So thanks everyone for being here.
Thanks, Kevin. Dan, you want to go first?
Sure. Thanks, Kevin. My name is Dan Murphy, and I am an engineered products manager for advanced drainage systems. And I cover Minnesota as well as the Dakotas and then a part of northwestern Wisconsin. I'm a civil engineer by training, and my specialty is really in stormwater and water resources and how to build systems to manage those. So what I do is most of my job is to work with engineers and designers during the project design phase to ensure that the products they're specifying that we manufacture are being implemented in the most efficient way, and that we're coming up with the most sustainable designs possible. So that's a little bit about me. I'll let you go ahead, Bryan.
Thanks. And good afternoon, everybody. My name is Bryan Miko. I'm an engineering manager for ADS. I work alongside Dan, primarily focused in the public infrastructure space and utility space. My background with ADS, I was a regional engineer for 6 years here, really working a lot on the material science side of things with our manufacturing processes, recycling operations, product design, R&D to come up with innovative ideas to use out in the field. I am a civil engineer by trade and licensed in 3 different states, Minnesota not being one of them, but in Illinois, Pennsylvania, and Florida. And I've done quite a lot of stormwater work all across the eastern half of the United States. So kind of a broader perspective from my end. Dan's local to you guys in Minnesota, and it'll bring some specific perspective to the things happening in Minnesota up there. But I spent quite a lot of time in Rochester and in the Twin Cities and really all across the state of Minnesota. So very familiar with it and glad to be here today. So as Kevin said, our presentation is really going to be 2 parts. The first part is going to just talk about some of the things that we've decided to do as a company to be more sustainable from a material source and waste management perspective. Our hope there is that you get to learn a little bit about the recycling process for plastics, and that you learn some things about how sustainable they can be and resilient they can be when it comes to buried infrastructure in the ground. The second part, Dan's going to focus some more on stormwater management projects, a few case studies that'll kind of give you a highlight of some of the things that we can do to be creative with stormwater and how to manage it in our ever-changing climates and environments that exist here in the Midwest. And we are really glad to be here today. All right. Our company recently has kind of gone through a rebranding, if you will, and really we are changing everything that we do to be focused on our key precious resource, that is water. And in particular, we've had a lot of experience with stormwater. For those that are less familiar with what happens to stormwater when it hits a community, the water that hits the ground and comes down from a cloud and drops in the form of precipitation doesn't just disappear. It doesn't just soak into the ground, especially in the urban environments that we've created, and go away. We have to find ways to manage that stormwater and that rainwater as it hits the ground. We have to make sure that we can capture it in a reasonable way and get it off of our pavements in our urban infrastructure so that you can safely travel and traverse roadways. We have to take that water that gets captured and we have to take it somewhere else. If we can get it to infiltrate into the ground at certain locations once it's captured, that's a great way to handle and mitigate the effects of stormwater. But a lot of the times that might not be feasible because you might have soils that aren't accommodating to just having water infiltrate in the ground quickly. So a lot of the times after we capture it, we have to convey it to a point of disposal or to a point of storage. That third category is kind of key. If our goal is to keep water on site and not let it go down into our rivers and our lakes and our stream beds, and we want to treat stormwater on site, a lot of the times you'll see in urban environments, either underground systems or above ground ponds and whatnot that allow water to sit and take time to infiltrate in the ground, and allows the specific development or the community to manage stormwater that way. And lastly, but certainly not least, as we put out stormwater into our natural waterways, we have to make sure that the water and the effluent leaving a property and heading downstream is not going to pollute those waters downstream. So whether it's excess sediment and trash that could enter our stormwater systems that are buried under the ground, or it's phosphorus that can be developed from a whole variety of sources, nitrates if it's more of an agricultural fertilizer and runoff issue. We want to make sure that the water we're putting into our streams or waterways or rivers or lakes is healthy, is clean for the environment too. So there's a lot of engineering and a lot of work that goes into making sure that when we do develop property and change our environment, that we're not going to change the ecosystems that could be impacted downstream to the best of our ability. So as a company and an entity, our goal is to be a good partner and a good solutions provider on how to manage and handle stormwater in each of these different life cycles of a raindrop as it hits the ground, gets captured, conveys, and goes downstream. Today we are facing even more difficult challenges in the Midwest probably than ever before. A lot of states and regions across the Midwest and the Northeast are updating how we design for and predict rainfall events and storm intensities, frequencies, and durations. We are seeing a significant increase in the amount of large rain events and storm events of supercells and micro supercells that can hit a community and hit a particular area with 8 to 10, 15, 18 inches of rain. And those changes are leading to a lot of investment into stormwater infrastructure, because when water gets to places it's not supposed to be, when it's not handled properly, it can lead to a lot of destruction as well. So it's our greatest friend and ally, but it's also one of our most difficult engineering things to deal with from a construction perspective. So with that context in mind, I did want to share a short video just to kind of introduce everybody to ADS a little bit more than me speaking to you. So please enjoy this video.
Water. It's the most precious natural resource we have. Advanced Drainage Systems is keeping it that way by preserving this precious natural resource for generations to come. Our industry-leading suite of sustainable water
Hey,
management
Brian, I can
products
hear it,
is
but I
highly
can't
engineered
see it, and I don't know if I'm the only
continuously
one
improved to solve for the
that can't see it.
I'm saying the same thing,
Can't
Kevin.
see it.
Okay.
Well, that might be a me issue, a streaming issue. So I'll try this one more time.
There we go. I can see the video now.
All right, let's try that again. Round 2. This isn't working out.
water. It's
Yep.
the most precious
Thank you.
natural resource we have. Advanced Drainage Systems is keeping it that way by preserving this precious natural resource for generations to come. Our industry-leading suite of sustainable water management products is highly engineered and continuously improved to solve for the entire life cycle of a raindrop. Capturing, conveying, storing, and treating. As the second largest plastic recycling company in North America, we keep more than 550 million pounds of plastic out of landfills each year, transforming everyday household items into pioneering products that last for decades. We believe in getting the job done right today for a cleaner, greener tomorrow. one where opportunity and well-being flows throughout companies and communities everywhere. We're problem solvers, groundbreakers, natural leaders. Our reason is water.
Okay. Have I returned to PowerPoint here?
Yes, you have, Bryan.
Okay, thank you. So now that you kind of have the big, picture in mind, I wanted to shift more towards why does ADS use plastics for sustainable infrastructure and drainage investments, and how do we incorporate the sustainable use of those materials into what we do? This definition that you see here on the screen actually comes directly out of a inspection document that AASHTO, which is a National Association of Transportation and Highway Officials, they came up with a new inspection guide for looking at drainage infrastructure, culverts, and storm sewers, and all the things that I've been showing you so far. And one of the critical things that our drainage infrastructure does is it protects our pavements, our bridges, our curbs, our homes from the destructive forces of water. If we didn't have drainage infrastructure, water would go wherever it would want to. It would find the path of least resistance. It would erode soil away, and it would devastate the very system that we rely on to get to the destination medical center, to through the city of Rochester, and to really all of our cities and communities across the country. Historically, our drainage infrastructure has been made with things like concrete and steel, and still is quite a lot today. But we are starting to learn and starting to shift more towards the use of inert materials, or materials that don't interact with their environment, for a lot of buried utilities, things like electrical utilities, gas, drinking water, sewer systems, because a lot of them are very susceptible, at least our aging infrastructure, very susceptible to the effects of corrosion. We spend over $100 billion a year fixing problems related to corrosion with our utility infrastructure as a country. Corrosion can be caused by a lot of different things. For stormwater infrastructure and for drainage, usually it's caused by a very difficult environment in which they have to exist. What you're looking at here on the screen is an example of runoff from a farm field, from an agricultural field. We use a lot of fertilizers to improve the yields of our crops, and to enable us to make and produce enough food to support our country and really the world. And a lot of the times when you get massive rain events that happen after the application of fertilizers, a lot of those contaminants can head downstream and can cause the stormwater to be very corrosive to metals and traditional materials like that. So as we've continued to develop and use some of those things, we've seen a greater and greater need for improved resiliency to corrosion from that aspect. In a more urban environment, I think we talk about salting agents and brines quite a lot from a sustainability perspective. We use them, are almost addicted to them in some senses, in order to keep our roadways safe for the traveling public. We certainly don't. It's not sustainable to have communities where human beings and human life is at risk because our pavements are icy and because crashes and collisions happen. But we continue to use a lot of salting agents and chlorides to accomplish the task of making them safer. Those chlorides, those salts, don't just disappear. A lot of the times they can trickle right through the pavement when snow hits and melts, or they end up in our inlets in our storm sewer systems, some of the things I was showing you earlier, that carry them and convey them downstream to our rivers, lakes, and etc. Those chlorides can be very damaging and corrosive to traditional infrastructure. So enter the idea of plastics. I think a lot of the times, especially lately, we think of plastics as a very wasteful material, and it certainly can be. But in a buried utility application where it's buried in the ground and it's serving a useful infrastructure purpose, it can be an extremely valuable material and tool. You know, we've spent many generations training kids and educating others on the potential value in recycling. And I think if you talk to anybody in the industry that is involved with recycling, you'd quickly find out that it's not as simple as we make it seem from a resource management perspective. And working here at ADS has taught me and taught a lot of us what it takes to really use recycled plastics as a way to take our waste streams that could be impacting other environments and ecosystems downstream and to repurpose them for something that's much more valuable down the road. So the next part here, I'm just going to kind of share what the recycling process looks like from our perspective. And if you have questions, and Kevin, if anybody wants to discuss anything here, feel free to interrupt me at any time. A lot of the times, our communities and our recycling operations from a municipal perspective really start with folks bringing recycled materials to the curb. These bins that we put out, on the street that get picked up by a truck and taken to a MRF, or a material recycling facility, contains paper, metals, plastics, glass, a whole mix of recycled materials. When those get picked up, they get taken typically to a recycling center. Those recycling centers then take each of those individual components, the paper, the glass, the plastics, the metals, and they separate them out into their main constituent components that I just listed for you right there. So what they're really trying to do is take those individual components and make them useful and really sellable enough to move on or to dispose of in a really true reprocessing operation. So, if things don't get sorted well, or if they just end up in a landfill, a lot of the times we tend to forget about them, right? It doesn't really impact us on a day-to-day basis until, a community or a local entity feels like they don't have the space to manage our waste. As a country, if we can't reprocess and reuse our waste and we don't put it in a landfill at a facility, we actually ship quite a lot of waste overseas, and even very recyclable waste overseas to Southeast Asia. So this barge that you're seeing here is kind of an example of what one of those, waste shipment barges would look like, to take it from, the western coast of the United States, or even eastern half through the Panama Canal and out to Southeast Asia. Over the past 5 or 6 years, Southeast Asia has continued to lack in their capacity and their ability to handle waste from the United States and from a lot of Western countries and civilizations. China, in particular, has been very challenging to work with over the past 5 years from this perspective, because they actually started rejecting some of our waste that wasn't to a high enough quality standard for them to reprocess and reuse in an economical way. There may or may not have been some political reasons for that juxtaposition, but regardless, our waste as a globe, and as starts with local communities, it's really easy to forget about it because it just disappears from our daily lives, and we don't think about what impact it could be having on other communities across the globe too. So ADS actually, for over 40 years, has been using recycled plastics in drainage materials. For the last 16 or 17 years, we've been investing in our own recycling facilities and capacities. The graph that you see up there on the top left is actually locations of all of our various plastics reprocessing centers across the country. So the one that's closest to Rochester would be in Waterloo, Iowa. And, obviously today, We're still working out of the difficulties of this past year with COVID-19, the pandemic. But in the future, if anybody was interested in doing, if this group was interested in doing a tour of one of our recycling facilities and could make the trip down to Waterloo, we would love to facilitate that. The folks that work there do a fantastic job, and that facility in particular recycles about 100 million pounds of number 1, 2, and 5 plastics every year. So really neat opportunity there.
Bryan, I have a quick question on that.
Yeah.
Thanks for the numbers of plastic. For the feedstock, or I guess for the products that you make, are they post-consumer recycled content or pre-consumer? Could you just let us know what the percentages and types are?
That's a great question. We do a little bit of both post-consumer and when you say pre-consumer, do you mean like, a
post-industrial or whatever?
Yes. Yeah. So we use as much as we can find of both. I would say probably 60 to 70% of what we use is post-consumer, and 30 to 40% is post-industrial or pre-consumer. So, let's, for instance, to explain what that means to folks, post-industrial or pre-consumer is, let's say Heinz, who we actually buy quite a lot of this from, their mustard bottles, they make them to a very specific color and thickness and specification. They're actually very particular about the plastics that they use and the quality that they put it out there on the shelf. Well, if they make a batch of bottles that don't meet their specs, they have to dispose of them. It's a food grade product. They can't just reuse it. So, if it weren't for someone like us buying those products, all of that plastic would go to waste. It would just go into a landfill and head downstream to the barge like you saw. So we buy all of Heinz's mustard bottles and other products too, that don't meet their specs, and it's really good plastic that can be used for a lot of highly engineered applications. Even though they intend it for only 6 months to a year on a shelf, we can take that and we can reuse it into what we do to last 50, 75, 100 years when buried in the ground. Post-consumer, on the other hand, is the stuff that I've been talking about to this point, where in your household, you take your detergent bottle, and when you're done with it, you throw it in the recycling bin, and it goes to a municipal recycling facility and gets distributed from there. So it's already gone through one use and life cycle. So I would say 300 to 350 million pounds of post-consumer plastics, and probably 100 to 200 million of post-industrial. I think my math is slightly off there, but you get the picture. So thank you for the question. That was excellent. So I'm going to kind of show what one of our facilities looks like, and the things that we do, the steps that we take to recycle plastics, and hopefully kind of explain how this all works. So this is kind of the starting point. We buy what are called bales. They're basically big rectangular, like a bale of hay, right? It's the same idea, just of plastic. So it's wrapped with a steel strap that we recycle, and when we uncut the band, but it's basically banded together, baled plastics that come into our facility. So at this point, a municipal recycling facility or a waste management or someone else, they would have already sorted between the paper, the glass, the metal, the plastics, and we would be buying just the plastic portions of the recycling segments that they offer. And they would work with other, reprocessors and manufacturers for the other components like glass and paper, pulp, etc. So it shows up at our facility looking something like this. We take one of those bales, we cut off the steel straps, we actually keep those to the side and take that back to someone for them to recycle and to reuse. And it dumps out into a conveyor feed system. So you can kind of see all the plastic bottles and packaging and all the different, components that we have going through here. And it heads up into our machine, our conveyor system and multi-stage process to turn this into a reusable material. After it's conveyed up into our off the bale and up into our machine system, the first thing that it does is that it separates out smaller plastics from larger plastics. Really, for the most part, the best plastics that we can use are the actual bottles themselves. The caps of the bottles are typically made out of different plastics than the bodies of them. The body of let's say a Tide detergent bottle is typically made out of HDPE or number 2 plastics. The cap of that bottle is typically made out of number 5 or polypropylene plastics. And we work with both of those. But one of the easiest things that we can do is knock away those caps, knock off those caps away from those bottles, so that we can separate those two different types of plastics in a macro way. The next thing that we do is that we actually have a sorting team, and this ranges in size depending on the facility and the throughput. But this particular facility is very similar to Waterloo. We usually have 8 to 10 line operators that are on the conveyor system, and what they're doing here is they're actually looking down at the different types of packaging, and based on our database of knowledge and their experience, they're picking off certain types of packaging that is not the right type of plastic. It's not a number 2 plastic or a number 1 or a number 5. And they throw that into that middle trough there, and we keep that separate and dispose of it, either take it to another facility that can recycle it or reuse it, or unfortunately, in some circumstances, there's going to be some waste generated from that.
Bryan, can you confirm the numbers of plastic that you use? There's a question in the chat.
Sure. So we recycle number 1, which is PET, number 1 plastics, number 2 plastics, which is HDPE. That's the most reprocessable plastic, actually, HDPE is. And you'll see in a lot of our, a lot of what we use, I would say probably 400 million of the 550 million pounds is number 2 plastics. And then there's number 5 plastics, or polypropylene. Those are the 3 most reprocessable, recyclable plastics. I want to say number 7s are like an other category, like a miscellaneous. I believe number 3 or 4s, there's like a polystyrene or something like that in there. In fact, I wish I had the screen just tilted up a little bit here, because actually the board right above this conveyor line has the number 1 through 7 listing and what they are, and example visuals of what they look like, in packaging, various types of packaging. So I'll see if I can get a visual like that for you guys. But that's something that if you just were to Google the recycling numbers and of plastics number 1 through 7, they would itemize it out. So for us, number 1, 2, and 5 are the 3 key segments. Great question. So after they've sorted through what we don't want, the rest of these bottles head downstream from there. And the conveyor system takes it to a massive grinding system. So it takes these bottles and it chops them up. It just makes it into what we call a flake. It almost looks like a multicolored, mulching system, if you will, for the bottles. And I wish I had a visual of it there, but I'll show one of it looks like a little bit later. So after we chop it up and grind it up into, I would say, the flake's no bigger than the size of your fingernail on your index finger. That's approximately the size of what the flake is. We run it through a series of wash baths. And this is really the most critical spot for cleaning and making the plastic reusable from a manufacturing perspective. The contaminants that can be on a bottle, include glues and adhesives that bond the label to the plastic, paper that is the label itself, metals, woods, other debris and contaminants that just are in the recycling stream because it's a waste stream. Other types of plastics. So if we're recycling, our operations are set up for number 2 plastics for the day. I actually don't want other plastics mixed in with that, because they have different mechanical properties. They have different manufacturing properties, and they can be very difficult to remove. So we use these wash baths as a way to separate out plastic from everything else. and to separate out other plastics from each other. So if you think about it, plastics are lighter than water, which is why they float very easily. So at the top of these wash baths, you'll see just a stream of the flake itself. And at the bottom of these wash baths, in those cones and those troughs in the bottom, that's where all the metals and woods and papers and other contaminants, drop out and dispose of, get disposed of and are sent to, and a conveyor system that, squeezes out the water and actually dries out a lot of the labeling and the additional contaminants, which is what you see here on the left. On the right is what I was referring to before when I said the word flake. That's what that ground up flake looks like when we chop up the bottles and after a series of wash cycles. And so we usually do 2 to 3 wash cycles before it gets to this stage itself. So I wish I could zoom in a little bit for you there, but you can kind of get a sense. Those, Gaylord boxes are about, I would say 3 feet high and 3 by 3 by 3 if they were a cube. So that's, you can see all the boxes that we have, staged throughout the facility and behind it, but that's all recycled, washed flake and HDPE and plastics. The last critical component to making these reusable is drying them. Moisture can be very, very dangerous to affecting the mechanical and the engineering properties of plastics for future use. This is probably the slowest and most energy intensive component of our recycling process. It's just because water is a stubborn resource and a stubborn molecule. So getting things completely dry for reuse is critical. After we dry that flake and we make it, basically clean and ready to go, we actually take one more step. And this is kind of a self-inflicted decision. At what we found is that in using recycled plastics for manufacturing, it's actually good to do one quick melt filtration system to do kind of like one final check on the plastic itself before we put it into our actual manufacturing devices and extruders. So what you're seeing out here on the screen is actually little pellets, which I'll show in a little bit, where we actually melt all of that flake that you saw. We chop it up, we extrude it and chop it up into little round pellets that kind of look like BBs. So this is what one of the screens look like, at the end of one of these melt filtration devices that we're using to, chop up and reprocess the plastic just one more time before doing quality checks. And you can see that when we add this additional step, all of these contaminants were still in that, bale of washed flake. And, when we manufacture products, we have screens like this that catch this stuff, but it's a lot better to catch this offline before you're actually manufacturing the product so that we don't have to shut down our machine, shut down our operations, and we can keep on moving and using the recycled plastic at a high output. And that's, again, an internal decision that we've made where we take, this step in this process offline and we do it ahead of time. We do a lot of quality checks on our recycled plastics. We have a database of over 2,000 different types of packaging that's come through our facility. And we do individual testing on Tropicana's orange juice bottles and on Heinz's mustard bottles and on, Tye's detergent. I'm using, big brand names that people recognize, but you can imagine the amount of variety and variability that comes through. And every time a line operator sees a new piece of packaging, we actually take that and we try to quantify, what are the material properties of this plastic that they're using and how do we, incorporate that into our system. We do all sorts of quality checks, like in the bottom left, you can kind of see it's what we call a float test. So the far left bottle is what you would see in the wash baths, where you have just water and plastics. That's, the mechanism we use to clean them. On the right, we actually change the density of that fluid. So we actually mix alcohol and water together. And what you see there is a separation of different types of plastics. So that gives us a good sense of how well did we, say, pull out, number 3 or plastics from number 2 plastics, right? And we can use a different density fluid to quantify how we're doing from a processing perspective. So We take all of those pellets, we send them out to our manufacturing facilities, and we use those, that recycled material, that recycled waste, to develop and create buried infrastructure products for stormwater management and for wastewater management. Actually, we do a lot of septic systems and rural wastewater treatment systems and sanitary sewer systems, et cetera. So, you know, there's been a ton of research, and I don't have a ton of time here. I want to leave, you know, some time for Dan, but AASHTO and a lot of national research arms, the Transportation Research Board, National Cooperative for Highway Research Program, you know, they've done a lot of research on the use of recycled plastics for, you know, engineering applications like a culvert or a storm sewer. And very recently, they have allowed the use of recycled plastics into the manufacturing process for use, you know, within the public right of way and on public projects by departments of transportation, cities, et cetera, with an assurance that the material will last for 100 years plus. So again, you know, the cool part of this story is that, you know, we are fortunate to be a part of a pretty cool initiative where we take things that are only meant to last 6 months to a year, and we repurpose them to last for, you know, 100 years plus when buried in the ground, and that can serve a purpose in handling and managing our stormwater. So hopefully you learned a few neat things about recycling. If anybody's got questions, you know, after the presentation, more than happy to address them, but I'm going to hand it over here to Dan now to talk about some of the cool things we're doing from a stormwater management design perspective and reuse perspective. So Dan, why don't you take it away?
Sure. Thanks, Brian. Yeah, so just for lack of a better analogy, Brian sort of covered how we, I guess, make the secret sauce there in our laboratory. But I'll talk now about kind of the dishes we can. Thanks for thanks for acknowledging that bad joke. But I'm going to talk about the dishes that you can cook with them, or how we actually apply our products within the project development framework. Especially beyond pipe for stormwater conveyance purposes, or simply just moving water from point A to point B. Kevin asked that I highlight a few of these projects, and I'm just going to go over a couple recent examples from Minnesota that we built or are building here within the last couple of years. This first example here is a specific detailed example of stormwater reuse, and the second is more of a typical regulatory driven project. After I go through this first example and before the second one, I'm going to explain generally the stormwater regulations that exist in Minnesota and do tend to drive many of the project design decisions that we are seeing engineers and architects making every day, and how those decisions actually dictate what gets put in the ground and how we're managing stormwater. It is pretty interesting, the regulatory environment in Minnesota related to stormwater, just because we have a very active community of academics, policymakers, and designers that we guys like Brian and I as product manufacturers get to work with on a daily basis. So both of the projects I'm going to highlight here, if you remember back to that first or second slide that Brian showed, kind of relate to the storage segment of the capture, convey, store, treat process. So this first project is actually from the Walker Art Center in Minneapolis, and specifically related to the Spoon Bridge and Cherry sculpture, which is located within the sculpture garden. It's probably one of the most iconic or popular landscape images of the city of Minneapolis. You can see below the sculpture that it straddles a pond. And if you look closely up at the stem, you can see a fountain right there at the tip of the cherry stem. And there's actually another fountain at the base of the stem that you can't really make out from this photo, but the intent there was to try to make sure that the stem looks shiny at nighttime. So it's a cool sculpture. It's very popular. It's very recognizable. But there were some, excuse me, definitely some improvements that could be made in terms of the sustainability. The sculpture was installed at the Walker back in 1988 when the sculpture garden opened at the Art Center. So it's been in place over 30 years at this point. So originally this pond was kept filled through the spring, summer, and fall, through the warm months. with treated potable city water, which after it ran through the fountain, overflowed into a drainage structure, and then down into the city storm sewer system and actually just back out into the Mississippi River. So the original thinking behind this decision was to ensure that clean water flowed through the sculpture fountain. So of course it wouldn't plug up. And secondly, so that the pond would stay nice and clean and attractive for all the people visiting the sculpture garden. However, as you can imagine, the unintended consequence of this decision to use clean, potable drinking water for aesthetic purposes meant that for 30 years, tens of thousands probably of gallons of that clean water were just being used once and then just sent downstream. So, you know, probably in terms of sustainability, not a very practical and probably a wasteful kind of practice. About a quarter of the city's water comes from treated Mississippi River water, and the remainder is actually pumped from groundwater wells. So to use, you know, this big amount of potable water, especially water drawn from aquifers, for aesthetic purposes only, with really no secondary benefit, you know, again, could be defined by many as unsustainable. You can also think about climate change at this point, and we know that warmer temperatures can negatively impact long-term aquifer recharge. So it really behooves us to minimize groundwater pumping to the maximum extent practicable, so we can maintain a sustainable groundwater supply into the future. So with this background, you can kind of put yourself in the shoes of the Walker Art Center Board of Trustees back in 2015. They knew that they had at that point, about $75 million to spend on the renovation of the museum buildings, as well as re-landscaping of the sculpture garden grounds over the next couple of years. So specific to the Spoon Bridge and Cherry sculpture and its use of massive quantities of potable water, how do we make this situation more sustainable? So their thinking kind of went like this. They have 11-acre sculpture garden with grass, shrubs, flowers, and trees that they irrigate every summer, so they can keep it looking nice for, you know, the over 1 million guests they get every year. So they thought, why not store what we use in the fountain and then use it again for irrigation and essentially have what we draw from aquifers each year. So this was the low-hanging fruit, so to speak, or in this case, the low-hanging cherry, to make a, thanks Brian, to make a much more sustainable system. And it's actually exactly what they decided to do. You can advance the slide, please. So we actually worked with the architects and engineers on this project and designed a 30,000 gallon storage cistern using our 60-inch pipe. The cistern, instead of the Mississippi River, would now receive direct outflow from the Spoon Bridge and Cherry Pond, and it would be stored there until it was needed by the sculpture garden irrigation system. So by installing, yep. Say that again, Brian. Sorry.
I was just going to say, I was wondering if you had another visual. Go ahead.
I do, yeah. So again, we were able to give the groundwater repumped for aesthetic purposes, I guess, a secondary benefit, or a second use rather, and that was to irrigate the grounds that were being irrigated anyway, again with potable city water. So, and not only are we saving water, but we're introducing the secondary benefit of alleviating pressure in the storm sewer system, because most of the water is now taken up by evapotranspiration, of course, after it's applied via irrigation instead of entering the city's pipes and flowing back out to the Mississippi River. So this is a picture of the underground cistern during construction. In the foreground, you can see the riser pipes that are used to access the cistern for inspection and maintenance. You see a conveyor boom truck there in the middle of the photo, backfilling the cistern pipes with rock. And of course, in the background, you see the cherry there, the sculpture. In the grand scheme of this project and all the improvements they did at the Walker Art Center, this particular piece of it represented a very, I guess, a minor cost or a small cost, but it resulted in a major improvement in the system's sustainability. So in general, I like this project example because I think it serves as a good reminder that there are opportunities all around you to improve sustainability, and you really do need to try to make positive changes where and when you can with the means you have available. So you can click, Brian. So before I talk about the second project, which again represents more of a typical case in terms of what we're implementing on a day-to-day basis, I just want to touch briefly and broadly on the regulations we're working with that have been in Minnesota in particular, that have been promulgated down from the Clean Water Act. That was passed federally back in the 1970s. So in general, on new development projects throughout the state, we have to ensure that a handful of major requirements are met. The first is stormwater rate control. That is, proposed rates of runoff from a site must meet existing rates. The intention there is to control the impact of increased impervious surfaces on both the existing built infrastructure around us, the roads, the sidewalks, the buildings, all the stuff Bryan mentioned in those first two slides, as well as the need to protect natural occurring downstream conveyances like rivers and streams. So when we add impervious surfaces, we increase the rate of runoff or how fast water runs off a site. And again, that can lead to overtaxed conveyance systems and lead to upstream flooding, downstream erosion in streams and lakes, and then of course, increased sedimentation and decreased water quality as an end result. The second major requirement that must be met is volume control. And that's related to the rate control requirement, but with more of a focus on the erosive effects of increasing overall flow volumes on downstream water bodies. Whereas rate control is focused on how fast water runs off a site, volume control is actually focused on how much total water runs off a site. And this is typically implemented by trying to infiltrate stormwater on site, or in other words, recharge that stormwater that you collect back down into the soil. The third major requirement that typically needs to be met are numerical total suspended sediment and phosphorus removals that relate directly to the quality of downstream water bodies. In general, the more of these you have in your runoff that end up downstream, the poorer the water quality is going to be downstream. So overall, what we're trying to do with these regulations is try to counteract the detrimental effects of adding increased impervious surfaces by treating the water, trying to infiltrate it, and generally keeping it where it falls rather than piping it away as fast as possible. As you'll see, what these regulations have done within our state have allowed for continued economic development without sacrificing the sustainability of our water resources. So we probably can't perfectly accomplish that sustainability piece, but we continue to make improvements. We try things. If they don't work, we keep moving on, and we continue to study and collaborate with the regulators and the policymakers and owners and developers to try to continue and improve the way we're managing stormwater. For a long time, developers used and engineers used the standard Stormwater Pond to try to meet these different regulations within Minnesota in terms of managing stormwater. What you're doing with the pond is, again, capturing the runoff from your site, slowing it down, allowing the suspended sediments in the water to settle out, and you're also providing storage so that you can more slowly release the water and help out with that rate control regulation that we see. But of course, these weren't a perfect solution, even though they were put in by the thousands through the 90s and the early 2000s. You can advance the slide, Bryan. Thanks.
We have one question in the
Sure.
chat too.
Yeah, go ahead,
Jane, would you like to go ahead?
I do have another meeting at the top of the hour, but if you're near the end, I can hold it.
No, go ahead, you're fine.
Okay, so I'll keep this very brief, but it'll be condensed. First, I'll introduce myself. Hello, everyone, and thank you. My name is Shane Kirpata, and my pronouns are he, her, they. Rochester is my hometown, which I care about deeply, but I currently reside in Berkeley, California, where I'm a public works commissioner and the vice chair of the planning commission for the city of Berkeley. I'm also a summer lecturer in the College of Environmental Design at UC Berkeley and a government and institutional facilities master planner in my day-to-day work. And I should mention that I'm speaking on my own behalf today. I'm a little concerned about the choice to use plastic for multiple reasons, especially when you're talking about infrastructure that is out of sight and too often out of mind. I'm curious what the degradation of these recycled plastics might be over a 100-year duration, what the maintenance costs over 100 years might be, when these might need to be replaced, but also what chemical leaching might occur from this choice of materials that will ultimately end up in our open waterways. I'm also concerned about the grooves in these pipes and how the freeze and thaw process in Minnesota might negatively impact the maintenance of this material choice, in addition to whether these can be recycled again after they've been used for infrastructure purposes. It's worth noting that 1970s legislation and policies are not up to date, so we might need to think 50 years in the future rather than focus on upholding the status quo of 50 years ago. I'm not trying to discourage anyone, but I do have concerns whether this is the best route for our shared future and the future of our children. Thank you.
Yeah, Dan,
Go
I don't
ahead.
know if you want me to address that. I appreciate you bringing up those concerns. I think that, you know, these types of forums are the place to do that. So thank you for being here and for voicing that. I would suggest to you that the plastics that we use and reuse into these products are extremely stable, and that they and we use a large amount of antioxidants to protect the material itself so that it can last from an engineering perspective. A lot of the times the plastics, like the single-use plastics that degrade and break down in our environment a little quicker, don't have those levels of protection for the material because they're not intended to last for 100 years and beyond. So certainly an excellent thing to be thinking about, and certainly something I would be interested in seeing more discussion and research on. But from that perspective, I would suggest to you that these are a lot different than the things that we're seeing out there from degradation of the single-use plastics that get thrown out into our environment and aren't reused. And when we reuse post-consumer materials, we revitalize them with that antioxidant packaging to protect them from degrading too quickly. If they degrade too quickly, you would likely see material failure and structural failure before you would see significant leaching of plastics themselves into the environment. Because they're under a lot of stress. These aren't just floating on top of the surface, they're buried under the ground. They're a soil structure system, and et cetera. I would also suggest that thermoplastics from a freeze thaw and a performance perspective are used quite a lot in northern climates. In Canada, a lot of the Nordic countries in Europe, in Minnesota, Wisconsin, all over the northeast of the country. And I would submit to you that there's plenty of performance data to show out there from that perspective that it's a very logical material to use and can serve its purpose. So thank you for speaking up, and Dan, I'll let you continue with some of these discussions here. So
I might just chime in with one last point, Dan, too, is this is just an educational session. So this isn't suggesting that we're using these products in any way for DMC or the city of Rochester, but rather just an opportunity to learn about ADS's approach for materials management and how they're used in their products. So, take it away, Dan. Thanks.
Yeah, thanks, guys. Yeah, I'll try to abbreviate this last portion here, but essentially, yeah, the Clean Water Act, 1970s, stormwater regulation, just to, I guess, reference a portion of that question. We've definitely come a long way from that. In the beginning, we were looking at total suspended sediments removal. We're looking at storing stormwater on the surface, and now we have moved into this idea of volume control, keeping things where they are, trying to infiltrate them back into the soil to maintain our groundwater levels. So there has definitely been a lot of movement since the 1970s. I did mention the 1970s as that was kind of the starting point for all of this stuff and this whole evolution of how we're managing stormwater. As this slide suggests, the stormwater pond may not be the panacea in terms of stormwater stormwater treatment rather. Even though we have a lot of them in place at this point in time, they now need to be maintained, and that's kind of introduced a whole nother complex issue that's turned out to be pretty costly. And there's a bunch of associated issues, including pH, as they're finding bound sediments, that sort of thing. You can click ahead, Brian, thanks. This is just an example of a pond dredging project and what you have to deal with after you fill up a pond with sediment. It's not a pretty sight. It's very disturbing to the surrounding activities that are going on, and it turns out to be pretty expensive and costly. Go ahead, Brian. So the idea to sort of move stormwater ponds underground came about probably, I want to say, in the early 2000s in Minnesota, with this idea that we needed to provide volume control aside from just rate control and water quality removal requirements. And that was to try to get water underground and allow it to, again, filter back into the soil rather than just store it on the surface. I'd add here too that when you're thinking about climate change in general, storing stormwater under the surface is potentially beneficial, as you're not allowing it to heat up via solar radiation all day long. So in areas in southeastern Minnesota where you have trout streams to deal with, and you're worried about dissolved oxygen levels and keeping those streams cool to allow those higher dissolved oxygen levels, this idea of storing water underground and not allowing it to heat up may become important. You can advance the slide, Brian. I was just going to run through an example of a project that we're working on currently and how stormwater is being managed in a typical situation. Not making any claims that this is the perfect way to do it or the best way to do it, but I did wanted to show you this is how it's being done, and that comparing it to the do nothing approach or even the put a stormwater pond on site approach, it may have certain advantages. So this particular project is located in outstate Minnesota. It's a typical box store setup. This one is a very big box store setup. It's a 2-acre site. A quarter of the site is building, and the remaining portion of the site is parking lot and landscaped areas. So what do you do with the stormwater here? Prior to this plan or this big box store being developed, this is just an open area that was wooded, grass, trees. Now we're introducing, almost 2 acres of impervious area. If we do nothing, we're going to have major issues downstream with water quality, erosion, taxing the conveyance system, etc. You can advance the slide, Brian. So in this case, to do that stormwater management on site without, again, sacrificing land area to a stormwater pond, the designers in this case and the owners elect to put things underground. We end up with two very large underground infiltration systems that allow us to capture water, recharge it back into the groundwater, as well as provide storage for rate control. You can go ahead, Brian. And this is a photo recently of this project, actually from this winter, and one of the underground storage systems. These are StormTech chambers. They're open bottom chambers that are installed in a rock bed to allow infiltration to occur. Go ahead, Brian. Actually, back up. I'm just going to make one quick statement on maintenance. Again, compared to a pond where you have to take a big operation to go in there every 20 or 30 years and dredge it out with heavy equipment. In this case, we're directing all the flow to a single row of chambers. And if you look on the pictures in the far back corner, you can see those access structures where we'd actually clean those structures out every year at a minimal cost if you finance it out over the long term versus one big lump sum project that takes the whole summer to clean out a stormwater pond. Go ahead, Brian. Another pipe storage system on site, like the Walker Art Center project. Here we're not infiltrating, we're just storing the water to more slowly release it. And this picture was actually just taken a couple weeks ago. That's all I have on those specific projects. Apologize for the kind of rapid pace there at the end. I guess we can open up to questions if anyone wants to hang out.
Yeah, thanks, Brian and Dan. Any questions from folks who are tuned in? I know we're at the hour, so folks may need to head out to their next meetings and stuff. But I guess one question that I had that came to mind as I was listening in was how common is it for manufacturers like yourselves of these systems to have the recycling kind of set up among other things. And then how do products like yours that have higher percentages of recycled content get specified compared to competitors? Is it something in the specs that cities or others can do in order to advocate for these things, in order for better environmental outcomes to happen with development projects? I'm just curious for your perspective on that.
I'd let you take that one, Bryan.
Sure. So I'll just take this one at a time here. So in terms of the ability for and who's out there that does what we do, we're kind of unique in that. We have our own recycling facilities and operations, and we take that the next step. So we've kind of vertically integrated there. There really is no other stormwater management product manufacturer that is similar to us in that regard. However, if it doesn't mean that other people don't manufacture products with recycled materials, because there are people out there that just make those, pellets that I showed you, and they reuse them for all sorts of applications, and they sell them to people who make extruded components and parts for toys and things, to other pipe manufacturers or chamber manufacturers, etc. So there are a lot of others that can supply and can provide a recycled material or blend to other manufacturers that make products too. I would recommend for cities, if they did want to incorporate that type of idea or technology, there are specific ASTM and AASHTO standards that can be referenced that have been, nationally developed, vetted through, the consensus building specification process at those two entities, and highly researched, that could be put forth, in a city specification or in a community's specification or in a development scenario. So definitely opportunities to do that.
Yeah, I guess I'm more interested or referencing, like, for gypsum board for projects. One of the roles that I've played in the past, but also here, is specifying 90% recycled content within the gypsum board that we're buying. Is
Sure.
information like that within those ASTM standards, or is that usually something that is in addition to a typical specification that a city might have? Like, I've never really seen that in an ASTM standard, I guess is what I'm.
Yeah, and there's a reason for that, but no, they do not state in any ASTM or AASHTO standards a minimum recycled content. And part of the reason that's done is because the primary goal of the standard is to make sure that it's performing as intended. And, that's the most critical piece. The only thing you would have to do is to essentially add to that specification, we want a minimum 50% or 60% recycled content. I think 50% is pretty typical in terms of what's specified for these types of products and applications, and that's what's been discussed with entities like Caltrans, MnDOT, and others who are looking at adopting this type of language. Their concern is, if we're going to require or want a sustainable product, we want to make sure that it is actually made with enough recycled materials too. So usually the language of contains minimum 50% would be very reasonable, and would be wide enough to not be a sole specification either. So thank you.
Great. Yeah, thanks, Bryan. Any other questions from the group still on the call? All right. Well, otherwise, I want to thank Dan and Bryan for your time. Really appreciate it. Good presentation. I definitely learned a lot, so thank you.
Yeah, thank you for having us.
Yeah. Thanks, Kevin, and thanks everybody for attending. Appreciate the time.
Have a great day.
Yeah, you too. Thanks.
Bye-bye.